Boom. But there it is. So there's your number line, your multiplication tables. No calculators for the first unit and a half until we get into like the end of exponents. No calculators or VU. Okay. Here we go, number skills. So on the front of these, I try and throw a rough schedule. Put your name here. My name is Mr. Dawidoff. This is block A. Because you are not the only math class that I teach that's going to get this. And if you leave this here, I want to know who to get this book back to. Dawidoff, block A. You guys are whatever your name is, block A. My other math class is block B. There is a rough schedule here. It might take us more than a day to get through any one lesson. Some of these lessons are large, and so if we need to take the time to review it, we're going to take the time to review it. I do want, as much as possible, I want you to stay with me. I know some of you guys might want to rush ahead. Don't rush ahead too far, because there are things we're going to do with these that you might assume the instructions are, but they're not. And so as much as you can, try and stay at least close to where we're at. I've got some quizzes labeled in here so you can have an idea of when the quizzes are going to be. So today we're going to start lesson 1, and if we finish lesson 1, then lesson 2 will be on Monday, lesson 3 will be on Tuesday. What that means is Wednesday, quiz. Thursday, Friday, Monday, Tuesday, Wednesday, Thursday, Friday. Like you can kind of start to get an idea of how this is going to go. There's page numbers that these page numbers aren't super accurate because I've done some editing and I didn't change the page numbers. But I do what I can to give you guys kind of a framework. I might, just for funsies, toss a quiz in between here that's not labeled. Just a, how are you at what we're doing right now snapshot. Here you go. Any student that I've taught that you might talk to, grade 10, 11, 12, will tell you, you might never know when Dawidoff's assessments are coming. Because I might toss a quiz at you. And I do that for... I have a very important reason, I feel like, why I do that. I like creating anxiety in my students. Let me qualify that. I like creating anxiety in my students over things that do not matter. Quizzes, ultimately, in the grand scheme of math, don't really matter. They are a snapshot on any given day of how good are you at the concepts that we've looked at. But we're going to do a unit test. And if the unit test is better than the quiz score, the quiz gets omitted. Doesn't count against you. The quiz only counts for you if it's better than anything else we've done. So I don't feel bad creating these little moments of anxiety in a really kind of a safe environment. Because if you don't feel anxiety safely when you're in a more dangerous environment, like a unit test or a final exam, and you start to feel anxious, then you're screwed. But if I can get you guys used to feeling the feeling of anxiety while you're working through math in a safe situation, like a quiz that doesn't mean anything, then you guys will function better when I give you tests or quizzes. And I do recognize that some of you, from what I'm told, might not have done any math tests in elementary school or middle school. Depending on who your middle school teacher is, I've had students come from Abbey Middle tell me they've never actually written a test. So this unit test might be your first one. I don't know. So I like to create little flashes of anxiety when the pressure is really, really low. Because when the pressure gets a little higher, then you guys get better at functioning that way, if that makes any sense. It's not like I like to torment you, but y'all need to learn. Okay, here we go. And again, like I said, this is going to feel like review to a bunch of you, and that is totally okay. Hang with me here. So, place value. We need to review place value and the language around place value. When we start identifying these numbers, I've got this number here. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a dot there, 1, 2, 3, 4. What's the place value we always start at? Ones. Ones is where we start. Ones is kind of the fundamental basis for everything. Which spot there is the ones? What value is in the ones? The 9. So this is the ones spot. If you are told to look at the ones, that's where you're at. It's the point, I'm going to make this decimal really clear. It's the point to the immediate left of the decimal, or if there is no decimal, it's the one at the far right end. So then let's work to the left from the ones. After you have a whole bunch of ones, then we roll over into the tens. We work, and it's called a base 10 number system. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you roll over to 10. After the tens, we have the hundreds. Let's pause there for a second and go the other way. This is the ones, that's the decimal. We've got tens and hundreds. What's this one? What place is that? Tenths. You betcha. So it mirror images off the ones. The ones are the ones, and there's only one. But as we go left and right, it's kind of the same pattern. From the ones, we go to the tens if we go left, and we go to the tenths if we're going to the right. That TH there signifies that we're in the world of the decimals and fractions. So next to the tenths, we have the hundredths. You got to have that in there. It sounds awkward, but there it is. THS. Hundredths. And we'll look at how you round to these. We'll just review how you round to these things, because this is something my Physics 11s are still really terrible at, is rounding properly. And so I want to make sure we review that here with you guys. Let's keep going to the left. We got ones, tens, hundredths. After hundreds, we have thousandths, or thousands, sorry. After thousands, we have, you betcha, 10 thousands. Then we have 100 thousands. I really didn't leave a lot of space there. After 100 thousands, we have million. And then it just kind of continues to cycle. 10 million and 100 million. And the pattern continues. After million, you have billion. And then it goes 10 billion, 100 billion, trillion. There are different... You know what? No, never mind. Forget I was going to say that. I'm not going to say it. It'll just add confusion. And again, it still mirrors to the right. You start at the ones. There's only one, and you keep going. If this was the tenths and the hundredths, then this is the thousandths. Thousand, DTHS, thousandths. And really, past that point, we don't use the names, even though the names do exist. We would just say this is the fourth decimal place. But the fourth decimal place does have a name. It's called it's the 10,000ths if it follows the pattern out. So this would be the 10,000 THS. And obviously this keeps going, right? We can go infinitely far in either direction, literally forever. We've got names for everything. At some point they become sort of meaningless, but they do exist. So the language there is important. And now we're talking about rounding. If we round to these different spots, give me an example of when it would make sense to round 3.8 to 4. Yes. What do you mean? But what's a scenario where it would make sense to do that? You're right. If we want to round to the nearest whole number, what kinds of things do we talk about in the real world where it only makes sense to talk about them as whole numbers? Ingredients? Yeah, like if you're shopping for something, you can't buy 0.8 of a banana. Like, you have to pay for the whole banana. Or if you're talking about people, it's the same thing. I don't care if you have, like, you're cut off at the legs. You have no legs. You still count as a whole person. There are objects, especially when we get into word problems, there are contexts where it makes the most amount of sense to only talk about whole numbers of things. So you'd round... Anytime you can only have whole numbers. When wouldn't it be appropriate to round 3.8 to 4? Yeah, like if you're baking by weight. Yeah, for sure. If you need the exact amount of ingredients. If it says 3.8 kilograms of an ingredient or grams of an ingredient, you wouldn't be like, 4's fine. Because if you don't know anything about baking, baking is an exact science. Cooking is not. You can get away with making things up as you cook. But as you bake, if you're not following the recipe exactly, the cookies aren't going to be cookies. They're going to be this disgusting little disc. You betcha. Baking's a great example when you're dealing with something like ingredients. Another example would be something like money. If you owe me 380 and I say, just make it $4. Or let's say it's bigger than that. Let's say you owe me $380 and I say, just make it 400. Is that going to fly?
No.
No. You're going to be like, no, I will pay you what I owe you and not a little bit more, right? There are contexts where rounding is not important or appropriate, and then there are contexts where it absolutely makes sense only to round. And we'll talk about these different kinds of contexts. Okay, what are the instructions for rounding? How do we round? Just so we're really clear on the issue. Yes, how do I round?
If I remember correctly, I believe you were supposed to only round up if you were at like 0.5 or higher, and round lower. I don't know if I'm saying that correctly, but like lower if you're lower than 0.5. Like if you have 3.5, then you round 4, wouldn't you?
Yes, okay. So, if you're talking about rounding to what place?
Round to the evenness.
Almost the whole number, the nearest whole number. I know what you mean. You're going to eat the language. The language is really important. So just so we're really clear, and again, I know that lots of you have been exposed to this, and it's going to be really boring for some, but that's okay. We're going to go through it anyway. Rounding. When you round, because you don't always round to a whole number. Maybe you're rounding to a 1 decimal place, or you're rounding to 2 decimal place. Maybe I tell you to round to the nearest 100 in your answer. Whatever you're doing, when you round, you always look one spot to the right from wherever you're told to round. So if I tell you to round to the nearest 100, where are you going to look? No, if you're going to round, I want you to round to the nearest 100. Look one spot to the right. So one spot to the right is the tens. If I say round to the 100, you look at the tens. If I say round to the 10, you look at the ones. If I say round to the nearest 1 or the nearest whole number, you look at the tenths. You always look one spot to the right from wherever you're rounding to. If the value is 5 or more, round up. If not, you stay. You don't round down. That value stays where it is, and everything past that becomes after you round. Everything right becomes what value? I know you're furiously writing. Yeah, 0. We don't just cut things off. It's important to recognize that we want to round properly. So we're going to do some rounding practice. Okay, so I've got a number here. I got 5.2498. If you need me to slow down, please tell me. If I want to round, yeah. I want to round that thing to the nearest tenth. So what value is in the tenths spot right now? Sorry? You sure? Where is the tenths spot? No. The 2. The tenths is one spot to the right of the decimal place. So I want to round to that spot. So if that's the spot I want to round to, where do I have to look? I look at the hundreds, what's in the hundred spot? A 4. Is 4 bigger than 5? No. So then the 2 stays a 2. So then this thing is going to become 5.2, and we could call this 0, 0, 0. The 4 becomes a 0, the 9 becomes a 0, the 8 becomes a 0, and now we've rounded this down. But when you have this, if it's a decimal, you don't actually need to have these zeros. We could just call this 5.2. Put your name on the board. Yeah, put your name on the board. Okay, hundredths. What is in the hundredth spot? Like, which spot are we looking at over here? Let's go someone else. Yes, Zach. The 4. So we're going to look one spot to the right. To the right of the 4 is a 9. Is 9 bigger than 5? Yeah, so the 4 is going to become a 5. And everything else to the right goes to a 0. To the left, it stays. So this is going to become 5.2500, or you could just leave it as 5.25, because after the decimal, you don't need these zeros. This and this are the same thing. And the thousandth is going to become an interesting one. In the thousandth spot, we have the 9. We look to the right. There is an 8. So the 9 is going to round to 10. What does that do? The 4 becomes the 4 goes up 1, and the 9 becomes a 0 to represent that 10. So then this thing's going to become 5.250, and then the 8 becomes a 0. But if we round this thing to the nearest thousandth, this thing's going to become 5.25. It's the same as this one, but because we want to round to the nearest thousandth, we actually have to have something in that thousandth spot. So it's not going to be 5.25. It's going to be 5.250. Good. I've got letters A through N. On your mark, get set, go. I will float around. I want you to crank these suckers out if you haven't already. Rounding practice, go. The 2 typos, that 0 should not be there for rounding to the nearest 1. And the other typo is this. If we're rounding to the nearest 10th, somehow this number changed from 36.5 to 35.5. It should be... The 10th is the 5, the 4 is less than 5, so that 5 stays. It should be 36.5. So those 2 examples are incorrect. I want you to get to the bottom of this page for homework. You still have 10 minutes left in class to do that. And a whole weekend. So that's what we're doing.